Our our next speaker for today is Bill Goodman from Thermo Fisher Scientific. Bill is currently Senior Director, Product Manager of Digital Science at Thermo, overseeing product management, data science, and solutions engineering teams with a focus on LIMS and cloud patterns. And he'll be telling us today about digital science, scaling from pilot to production through orchestrated collaboration. So over to you, Bill.
Perfect. Thank you. And we just had our own little mini example of how we are all connected yet very disconnected. Thought I had emailed my slides, but it turns out they were too large to email. So they didn't get to the allotrope team. So now we just did the dance, which we do too often in the lab, which is somebody run and find a USB stick. Hopefully that USB stick did not have anything malicious on it. And now here we are. So we made it just in the nick of time. And I thank everybody for their patience. And actually the conversation prior to this that Ryan and the group in the room had is super helpful because, what I want to talk about for the next 20 minutes here is really how are we starting to put these pieces together alongside specific customers to solve a lot of these problems, right? To really think about how do we get to scale? How do we deliver on the business promise that we aspire to? And along the way, how do we leverage standards, interoperability, fair data, et cetera? You'll notice some themes in here that are going to hit on a lot of what the foundation that Richard and Ryan more recently laid. Starting off, obviously, with the customer, right? Really making sure that we think about you all in the room as well as the other customers around the world and what their goals are and what their business problems are and using that as our North Star. And then working through what is an ecosystem? How do we think about ecosystems? How do we think about configuration of ecosystems to be able to add that value? A bit of a discussion around the lab of the future. Obviously, a term that's not so futuristic these days. I was trying to look back at some of the when we started having Lab of the Future conferences and things like that. It's certainly I think we would have thought we were going to be coming here in flying cars when we started having Lab of the Future conferences, and fortunately, we're just sitting in Ubers that aren't going anywhere. And then lastly, hitting on that collaboration piece. So this previous conversation really teed up very perfectly a lot of what we're doing, a lot of where we're going, and a lot of what we think is essential to get there at scale. So this slide probably looks familiar from Richard's presentation yesterday. Not going to dwell on it for too long, but I do want to hit on a few things here, right? So obviously, as everybody's mentioned, we're accumulating lots and lots of data, and we all have great hopes and dreams for that. But it does present challenges, both around just the cost of maintaining it, but also how do you architect it, how do you keep it secure, and then how do you position it for use? And alongside that, we also have these environments that are continuing to just get more and more complicated. Obviously, we mentioned tech debt, we mentioned cost of ownership, we mentioned driving use of those tools, right? In many cases, you may have pockets of use, but not everybody's using it. So, real challenges around that. And then obviously underlying all of that is, in some cases you can't actually use it, you can't actually find it, et cetera, et cetera. For us, what we really think is on the right side there's three key pillars of how do we start to solve these problems? How do we start to make progress? And one of them is really, making sure that we're recognizing the environments we're in. Right, they're heterogeneous. They're old. They're new. They're homegrown. They're COTS. They're all over the place, right? So we can't assume or ignore that. We have to design for that. We have to be thinking about how do we improve the experience of the scientist, right? If we don't make tools that have really good experiences in them, people are just going to say no, thank you, right? They're going to get confused. They're going to get dejected, and ultimately they're going to opt out and just continue to do things the way they are. And then the last bit is obviously we've talked about it a lot, thinking about positioning that data for many types of reuse, including sort of advanced computation, machine-based use cases, AI, et cetera. And then with that, we can start to get closer to realizing the goals we have with the unified scientific ecosystem. And I call these out early on. Oh, look at that. That's a surprise. I call these out early on because these are the sorts of things that we want to make sure we keep front and center as kind of our North Star as we look at these projects and as we think about where we're going. right? We want to make sure that we're able to use data. Oh, that's great. To unlock the time that our scientists have available, right? To think about automating their tasks, to be able to prevent them from spending time on mundane, repetitive tasks, to leverage their history, and then to ultimately do their job better. And one thing I do want to call out, and Ryan talked about it a bit, is that for us, this is both an internal and an external problem. So one of the things that's, for me, a hugely delightful about working within Thermo Fisher is that we have internal colleagues who do CRO day in, day out. We have internal colleagues who do CMO, CDMO day in, day out. So we can sit down in a way that's far more open, sometimes a bit more blunt than perhaps other interactions, and get real feedback really quick. And that's hugely valuable. But additionally, we can also sit down with colleagues who spend their days thinking about all the physical things that we have in the laboratory. Everything from, high-end mass spectrometers and microscopes all the way down through to reagents, consumables, media, all those sorts of things. And we have to remember, like we talked about yesterday, ultimately we're looking to use data to do things in the physical world more efficiently. So we have to make sure we're thinking about that connection between digital physical, as well as the pieces on the data side. And so as we think about this, as we think about orchestration and we think about the path we're on, apologies here. What we're seeing is that this exists along a continuum. We've talked about wisdom. I think we talked about wisdom. Vinny was mentioning wisdom earlier, knowledge, information, data, right? This exists along a continuum, and we really want to continue to move up and to the right. I think we're all past that foundational stage at this point, right? We probably all have a sea of applications that are allowing us to get most of our information into computers somewhere. The next phase of that starts to become more about how do we realize that value? How do we move up and to the right? And ultimately, up and to the right is a place of high value. Low and to the left is a place of low value. And as we're looking at this, I think many of us are starting to find pockets of integration, pockets of success stories, pockets of value from orchestrating and integrating these things and actually driving towards some level of automation or data-driven decision-making. From what we've seen, it's not quite at scale yet, right? We still have some ways to go to be able to really say, hey, we've achieved this at scale, and we're solving for big, meaningful business problems day in, day out. And, really where we're looking to go is, at least one more step over the foreseeable future, but hopefully even more, right? Hopefully we can move towards a place where we are solving routinely at scale. And some of the things that we need to be looking at, that we need to be understanding to be able to do that, are called out here in kind of a high level view of what we believe the ecosystem should look like. This slide is one that sometimes gets confused. Sometimes I see it as a solar system, others see it as a target. But we'll just assume that our science and our people are the sun, and we're all kind of rotating around them. If you want to look at it as target, then they're pretty good at data science as well. So really, this starts with our science, right? And who does our science? Who's closest to our science? It's all of the people, right? It's all the people who we enable with our tools. It's all the people who we have in our laboratories, and they're ultimately the ones who are unlocking the important insights to be able to do this well. And what do they have, right? They often have their applications, right? Most of our work is done in front of a computer. So obviously the applications are that next layer out, and those people need effective tools, effective applications. Those applications obviously are important to be able to be doing your assays, your analyses, your measurements, and with beyond that, you have your data, right? Those are your portals into your data. And then when you combine all those things together, you have your people, you have your tools, you have your data, you can start to generate the knowledge necessary to be able to do what we want to do. And I think yesterday there was some talk about making medicines and making shampoo or whatever it may be. But ultimately in our scientific based industries, we're using that science to create some sort of useful product for people. And what we think is that a lot of that needs to be enabled and orchestrated and through some sort of platform, right? And that platform should really have a couple of key sort of capability sets in it, right? One is about orchestration, right? How do we reduce the time spent on routine mundane tasks, and how do we allow for both standardization through data as well as creation of standardized data to be able to drive more efficiency, drive delivery of better insights, et cetera. So not surprisingly, right alongside that is kind of a data pillar, right? You can't really have one without the other. So it's somewhat of an artificial separation. But on the data side, there's a whole lot to do, a whole lot to consider. So we have those two standing up there side by side, but they're really working together, right? Perhaps they're in a loop there where you need the data to inform the orchestration, and then the orchestration creates more data, and so on and so forth. And those things can stack up into various sorts of use cases. There's a few examples on there, and then ultimately into some sort of experience or workflow. And you're saying this is great. I need to see some examples, right? We've been talking about all of this since the first Lab of the Future conference, probably 20 years ago. So this is how we're thinking about it. And we've had a few conversations at lunch, and I think Richard showed this slide yesterday as well. He mentioned it at a high level. I want to dive into a few of the important pieces, right? So if you look front and center, there's a whole bunch of stuff in there that we call the platform. This stuff is not necessarily exciting stuff: identity, access management, entitlement, so on and so forth. But it's critical for the foundation. And I think Ryan might have departed, but what I'll say is that we go through the same sort of rigor for developing our own applications as we do when we're buying other people's applications. So in terms of security, in terms of data integrity, in terms of all those pieces, what we've focused on here is building out a really, really solid and stable set of capabilities that can be reused across in many ways. And this is a thing that I believe is really important for us as a vendor to have done really well, because there's a whole lot of tech debt in there. And if everybody were to go out and redo all these things themselves, then everybody would be absorbing that tech debt. So there's some real, sort of benefit of economy of scale to be had by coming up with a mechanism to have this shared sort of central foundational group of capabilities that can be just trusted, managed in such a way that you don't have to worry about it. You don't have to have loads and loads of time and effort spent on tech debt. To the left of that, there's a couple of different ways to get information in. I think this is a really important aspect. Not necessarily a focus of the meeting today, but as Allotrope looks forward, I know, Vinny, that you mentioned some integration with experiments, some round trip ideas, things there. How do we leverage data into and out of systems is super important. Obviously, as we think about the systems of the future, which need to be as open as possible, which need to accommodate heterogeneity, having the ability to have a lot of flexibility of how you communicate in and out is super important. That could be, modern API-based communication. That could be communication through some sort of edge appliance. Things like OPC UA and other types of interactions are all sort of important there. But obviously, connectivity in and out needs to be super straightforward. And that's really, like I said, an important aspect of how we accommodate heterogeneity. And then in the middle there, I mentioned it a little bit before, you have workflow orchestration, so kind of business process automation, which leverages connectivity, which leverages data, which allows you to simplify tasks. The task could be that I'm going to save my PowerPoint presentation for a conference, and that's going to automatically get shared with, a few folks within the Allotrope Foundation, and then it won't have to get showing up here with the USB stack. But that same sort of task list and that same sort of workflow can be also very important in the laboratory. And really, when we're thinking about this workflow orchestration, it's really at that level where the top level of the laboratory, or the level where the laboratory starts to span into the business. So again, it was mentioned this morning that we need to be thinking about solving really valuable business problems. In many cases, those business problems span out systems that live outside the laboratory. I'll say from some of our experiences recently with customers, two of the most common systems that folks want to be able to have visibility into are their learning management system and their workday system, right? And because, if someone's not trained and they're on vacation, that's an important thing to know as you're planning work in the laboratory, because, if there's no person there, or there's no person who's trained there, then it's kind of hard to get the work done. So when we're thinking about these, are really top level workflows that are spanning out into different parts of the organization, and really allowing you to plan work at the very highest level in the laboratory. And then on the right side, And this is where, you know, further collaboration with Allotrope and ASM and other pieces come into play is really how do we position that data for use by data scientists? We have AI enablement in there. I could say the enablement piece is the important bit, right? How do we leverage scaled infrastructure such that we can reduce the amount of time spent on data engineering? And as you can see, there's loads and loads of little boxes here. This is a group of sort of configurable services, configurable modules. So these things are, you know, meant to be deployed in flexible ways. One of the places where we're still working with customers to nail down all of these is exactly how configurable, how flexible do we want to be. So that's still a work in process. And then all of this sort of goes into this slide, and I apologize, it's still not a circle. I was going to bring a printout of it and kind of turn it into a cylinder, but maybe we can just all imagine it as a cylinder. I don't know that I'm good enough at folding paper to make a Mobius strip, Dave, but maybe I'll practice, and then next time we can do that. But this all starts to flow in as we think about this lab in a loop, right? As the wet lab, dry lab, wet lab is integrating those tools in the wet lab or in the dry lab to be able to, in a more efficient way, plan and execute the work in the wet lab, and then to be able to pull that data back into the dry lab in a comprehensive and efficient way, right? So as we think about this, it's not only driving those workflows, it's more about driving the workflows in between the dry lab and the wet lab than it is about necessarily having any sort of single piece of that equation, and really finding the points of vertical integration so you can pull in your existing and your aspirational systems on the dry lab or your existing vertical applications in the wet lab, and creating automated workflows and automated data transfer between those systems, so that way we can get the scientist out of doing a lot of those manual tasks, and we can also have that data transferred in a comprehensive and consistent way. It's going to show up. All right, so I apologize, some builds in here. So what I wanted to do in this slide was to really give you an example, right? This is kind of a stylized version of a real life example, and that I think demonstrates how we're approaching collaboration really well. So what this is really an approach that puts the business value first and foremost, right? So sitting down together with both customers and other vendor collaborators and identifying valuable business problems. And I say problems because in many cases you start off with 3 or 4, right? There may be 3 or 4 problems that are interesting to the business, but there may be a change management issue on one of them. There may be a technology issue on another one of them. So finding the ones that are both valuable and reasonably attainable is really critical. And doing that first and foremost is the first step from what we've seen to setting a project up to move past kind of pilot purgatory or POC or what have you, right? So, and I'm not discounting the value of POCs or pilots, right? You see that that's kind of the third step in the process here, but I think planning for scale, it requires you to have a very, very clear articulation of the value. And then building a team around that problem to start to create an environment where trust, credibility, and partnership can form, right? And what I'll say is, you know, it requires work for all of us to move from a traditional customer vendor or vendor relationship into a group of relationships that are open and trusting and productive. So really focusing on building that credibility and partnership. And that's one of the key aspects of doing a POC, right? And I think there's two key aspects to leveraging a POC as a path to scale. The first one is building a team, right? The team has to get together. They have to roll up their sleeves. They have to start doing real work. The second piece of it is you start to identify the unknown unknowns in the actual project, right? We may come in with a group of capabilities that we understand very well. You have an IT ecosystem that we don't understand at all. You have a bunch of processes in the lab that may be different than what we've experienced before. They may even be not fully understood. So the value that we see in the POC is really ferreting out all the landmines or some number of the landmines that we might hit on the path to scale, and working through those in a rapid and agile way such that we can start to generate positive momentum. And to have open and honest conversations, review these things where this may sound agile-like, right? It's kind of based on many of those principles of generating momentum, having reviews, showing results, and then moving on. And then what we've seen from there is once you kind of exit that phase, you're able to go into planning larger projects with a lot more trust, a lot more understanding, and ultimately able to come up with a much better plan for your path to scale. And this is something that we're doing now. This is something that we're having success with now, and something that I really wanted to share with the group as a a mechanism that we both welcome and recommend, right? So to be able to really dive in with these focused projects and work together as a team across the organizations. And with that, we're starting to think about engagement very, very differently, right? We're starting to think about how do we continue to drive towards partnership, both partnerships with standards groups like Allotrope or Pistoia or others, as well as how we together start to get better at working between the vendors to be able to have approaches that are more open, less friction. We still have work to do there. It's still not easy. And then ultimately, how do we make sure we have the right folks engaged within the various businesses such that they can have open and honest feedback. They can have, the way we're doing it today is that, they have input into the engineering teams. They have input and ability to help prioritize work that's going on both near term and long term. We potentially even have teams working together to develop future state capabilities, really based upon the priorities and the needs of the business or businesses involved. So from our perspective, what we really see is that as we look towards this future state, we need to have not only the technical solutions, but also the structures and engagements across the various organizations to be able to make progress. Again, I think, Vinny, you mentioned it this morning, right? There's a lot of work to be done here. There's a lot of a very broad playing field of technology, which we need to be able to leverage into a very wide variety of workflows. And nobody's going to do it by themselves. And the more that we can work together to divide and conquer that work, the more likely it's going to be that we're going to succeed. So with that, I say thank you and happy to have any sort of discussion, conversation that folks are interested in.